So in section 6.6, we finally start solving some log equations that are more complicated than the ones we've seen in the past. The key to this section and to solving both logarithms, logarithmic and exponential equations is being able to classify it. So first you're going to classify it as either a log equation or an exponential equation. And then you're going to further classify it based on the types that I've got on the handout. The listings of the titles are mine. So if you go Google searching for it, you may not end up with that same exact type of equation. So please recognize that. The first one we're going to solve for what we're going to call log equations, where you have log on every term except for one term, which is a constant. So you have log equal constant is what I call it. So this is what we're going to call type 1. Again, the numbering is just to help us connect during the lecture. And it's log equal constant. And again, what that means is that there's a log on every single term except for one term, which is just a constant. So what you're going to do is you're going to move all the logs onto the same side. So you have logs on one side, the constant on the other side. You're going to combine the logs into a single logarithmic expression, and that's using the properties in the previous section. You're then going to switch to exponential form. Finally solve that, and then don't forget to check the domain. With logarithms, remember that the log function, when you graph it, looks like this. And its domain is from 0 to infinity. So we have to be able to take the log of a positive number. So, okay, for number 1, our very first example, we're going to come in and solve log base 2 of the quantity 1 minus 2x is equal to 3. So when I look at that, I recognize I have logarithms on one side, a constant on the other side. It's already a single logarithm, so I don't need to do either of the first 2 steps. We're just going to switch to exponential form. So this is where we're doing our little lassoing bit. We're doing this bit. So we're going to pick up the 2 as our base. We're going to raise it to the 3rd power and set it equal to 1 minus 2x. And then we can solve that. This is a nice linear equation. We're only going to get one answer on this. 2 cubed is 8. That's equal to 1 minus 2x. 7 will be equal to negative 2x. And then finally, negative 7 over 2 is equal to x. So we get an answer. And now we're going to check that answer. So we're going to take that negative 7 halves, we're going to plug it right back in. So this is me, and usually this is just a mental or verbal check. So I'm taking the log base 2 of 1 minus 2 times a negative 7 halves. So I got a negative answer. That's not what the problem is. Negative 7 halves times a negative 2 is a positive 7 plus 1 is 8. So I end up taking the log base 2 of 8, which I can do. So that's as far as I need to take it. I know that's correct. Notice you can take it one step further. This is equal to 3. So 2 to the 3rd power is equal to 8. It actually does work, and we can see that. But more importantly, we're ending up taking the log of positive quantity, which is all we're checking for. Okay, in example 2, there we have log x plus log of the quantity x plus 15. And that's equal to 2. So again, I see a log on a term, log term, and then a constant. So it's the fact that I have a single term without the word log on it that makes it this type. This time we do have the logs on the same side, but they're in 2 different places or expressions or terms. So we need to combine them into a single term. So because there's a plus between them, we'll use our product property and rewrite this as the log of x times x plus 15. And that's going to be equal to 2. So those were the properties letting us do that. We know the base here is 10. Now we can switch form. So this would be 10 to the 2nd power is equal to x squared plus 15x, just distributing in. This is 100. And we have a quadratic. X squared makes this a quadratic. We're expecting 2 solutions to come out of solving the quadratic. So we'll set it equal to 0. That's going to give us 0 is equal to x squared plus 15x minus 100. Factor, if they don't factor, use the quadratic formula. Most of them will factor though. So factors of 100 that are going to subtract to 15 to 20 and 5. So this factors into x plus 20 and x minus 5. So we see x is equal to a negative 20 and x is equal to 5. So we've solved it, but now we have to check them. So I'm going to pick up this negative 20. I'm going to plug it right here for this x, and that would give me the log of a negative 20. Which we can't do. So that one is no good. Let's check the 5. Plugging the 5 in will give you log of 5. That's fine. Over here, if I plug in 5, I'll get 5 plus 15, which is 20. Log of 20 works. So the only one that doesn't work is the negative 20. The 5 is a good answer. Okay, one more of this type. Example 3. Example 3 says we have 2 log base 5 of the quantity x minus 1 is equal to 1 plus log base 5 of 4. And let me clear some more boards so it doesn't look all jumbled here. So again, I see one term that has no logarithm on it. It's just a constant. I need all the logs on the same side. So I'm going to go ahead and move this log base 5 of 4 over to the left side. The other thing I'm going to do in the same process is recognize that the 2 out in front can be brought inside as an exponent. And I do need to do that first. So I'm going to have log base 5 of the quantity x minus 1 squared minus log base 5 of 4 is equal to 1. Now we'll combine the left side into a single logarithm. So it's log base 5 of x minus 1 squared in the numerator over 4. It's a quotient because there's a minus between those 2 log terms. You can see those log properties in play, right? So now what we're going to do is change into exponential form. So this would be 5 to the first power is equal to x minus 1 squared. 5 to the first power is just 5. At this point, let's clear the fraction. Multiply both sides by 4 to clear the fraction. So that's going to give me 20 is equal to x minus 1 squared. I tend to go the most efficient route. I'm going to square root both sides. So that's going to give me plus or minus the square root of 20 is equal to x minus 1. And all I'm going to do is move the 1. So I have the 1 plus or minus the square root of 20. Don't forget to simplify your radical. 20 is 4 times 5. So that would be 2 square root of 5 is equal to x. Okay, now that's an exact answer. We do need to check them. So 1 plus 2 root 5 is a positive quantity. If I plug it in and take away 1, because I've already added 1, taking away 1, I'll definitely get something that's greater than 0. And this is a constant over here, so we're good. But plugging in the negative, this would be x, sorry, it would be 1 minus 1 minus 2 root 5. Those ones are going to cancel, but I end up taking the log of a negative 2 root 5, which I can't do. So the only solution to the equation is 1 plus 2 square root of 5. And there it is. And that's our first type. So again, the key is that one of the terms is a constant. Everything else has the word